Hi, let's see this result. The class of DCFL is not closed under concatenation and Kleene star operation. So we will see some counter example for this. Consider this language L, and this language is basically your a power n, b power n, c power k, and k is greater than equal to 1 union a power n, b power k, c power n, and k greater than equal to 1. Now you consider this language L. This language L is a standard non-DCFL language. You can clearly see why this is not DCFL, because in this language you can see that either we have to check number of a equal to number of b, or we have to check number of a equal to number of c. So basically this language L has two parts, one part this and another is this part. Okay, so this is not DCFL because we do not know whether to check this or whether to check this. So that is why this is not DCFL. Now consider another language. So let me call it L1, and now let me call it L. And this language L, what I am going to do, I am going to do like this: a power n, b power n, c power k, and n k is greater than equal to 1, so I am just not writing it. Okay, and a power n, b power k, c power n. Here I am putting d here. Okay, so you can see what I am doing. I am doing a power the same, a power n, b power n, c power k, and here I am doing d a power n, b power k, c power n. Now this L, this is a DCFL. Why this is a DCFL? This language L, this language L, if you see. Okay, so this language L, now this is a DCFL, because now everything is clear, push and pop, everything is clear. Now what we will do, okay, for example, first you will push all the A's, then if your string starts with D, then you will check a power n, b, a power n, c power n. If your string does not start with D, then you will check a power n, b power n. So basically this D will tell you whether your string belongs to this part or whether your string belongs to this part. So that is why this L is DCFL. You can clearly see why this L1 was not DCFL, because here we did not know whether our string belongs here or whether our string belongs here. So that is the point. Now this L is a DCFL language. Now consider another language. What I am going to do, I am going to take another language. Let's take L dash, and that language is basically empty string comma D. So this is a very simple language. L dash is a finite language. Only two strings we have. One is empty string, another is D. Now you need to consider L dash dot L. What is this? Okay, so this is a concatenation of L dash and L. So what is this language? This is basically this dot L, and L is this. Okay, a power n, b power n, c power k union D a power n, b power k, c power n. So this is our L. Now if you see, this will be basically your if you do the concatenation, then what you will get? You will get L union DL. Now if you do this L union DL, then what you will get? So this L is as it is. So this L, a power n, b power n, c power k, okay, union D a power n, b power k, c power n. So this L is as it is, union DL. DL means now you will concatenate this D with this L. So you will get D a power n, b power n, c power k union D square a power n, b power k, c power n. Now this language that you have got L dash dot L, this language is not DCFL. You can check it out. Why it is not DCFL? See, you can clearly see in this language you have four parts, either this or this or this or this. Now if your string starts with D square, then you can say that your string belongs to this part. If your string does not start with D, then you can say your string belongs to this part. So this is clear, these two parts are clear. But what if your string start with D? Then you don't know whether to check this or whether to check this. Basically, if your string starts with D, let's assume your string is this D and then some a power n, and we don't know what is this, what is this. Okay, now if your string is starting with D, now I don't know. So of course I will push all the A's, but now I don't know whether to check A power n with C power n, or whether to check A power n with B power n. So that is why I can say that this LDAS dot L, this is not DCFL. Now from this you can very easily see that this LDAS is finite language and every finite language is regular. So this LDAS is DCFL, every regular language is DCFL. So this LDAS is DCFL and this L is also DCFL, but their concatenation is not DCFL. So the first result that we got is that DCFL concatenated with DCFL, that may not be DCFL. So this is the first result. DCFL concatenation with DCFL may not be DCFL. I can say that may not be DCFL. Okay, so this is the first result that I got. Also you can clearly see that this LDAS, this is a regular language. So I can also say this result also I can say that if you have a regular language dot DCFL language, means regular language concatenated with DCFL language, that also may not be DCFL. So basically I can say that DCFL languages are not closed under concatenation with regular languages, so may not be DCFL. Okay, next you can see, if you consider this language LDAS, then this LDAS is a finite language. So I can say one more thing, that DCFL languages are not closed under concatenation with finite language. So I can say this finite language dot DCFL. So if I concatenate DCFL with a finite language, then also I can say may not be DCFL. So these three results we got from this simple example, from this very simple counter example. These are the three results that we got. DCFLs are not closed under concatenation. DCFL are not closed under concatenation with regular language. DCFL are not closed under concatenation with finite language. So these three important results that we got. Now after this, let's see Kleene star. So before we see this Kleene star, again we will take the same language L, and our language is same: A power n, B power n, C power k, union A power n, B power k, C power n. Okay, so okay, D. Now this is our language L. We have already seen that this is a DCFL language. Now what you consider after this language L, we have already seen that this language, this simple language, this language is not DCFL. This also we have seen. Okay, so this is not DCFL. Now consider this language D star dot L. Is this DCFL or not? Think about it. You can pause the video and you can try to think about it. What is this D star dot L? You will see that this is also not DCFL. Same reason. Why? Because what is this D star? This D star will have empty string, it will have D, it will have D square and so on dot L. Now again the same thing will happen, the same thing here, empty string comma D dot L. So here also we have empty string comma D dot L. So again the same thing will happen again. If your string starts with D, then we don't know whether which part we should check. So again the same thing, you can just work it out. This is a very simple variation. This is a very simple variation of this. So we can say that this is also not DCFL. Now consider a very simple one more variation. Consider one more variation. In this, what I am going to do, L union D. So basically in this language L, I am going to put this string D, and then I am going to take the Kleene star. You can see in this language L, if I put just one more string D, then that does not change anything. So basically this internal thing, this is DCFL, means this L is DCFL, and we do the union of L with this this finite language. Only one string is there, so this language is also DCFL. Now this DCFL whole star, what is this? So this is DCFL and this is the Kleene star. Now this result, what is this? Whether this is DCFL or not. So you can clearly see, if you got this example, okay, if you understood this, then you can very easily see that this is also not DCFL. Why this is not DCFL? Let's talk about it. So what our L is clear. Let me just write it again. So union A power n, B power k, C power n. Now what I am doing L union D and whole star. So in this language L, I am putting this one more string D, and then I am taking this Kleene star. So what I will get? Okay, this Kleene star means you can repeat any number of times. Again, this type of scenario will happen. Basically, you will get L, you will get this D. What more strings that you can get? Basically, you can get whole square. Whole square means again the same thing. Basically, you will get D dot L also you will get. Okay, and many more things you can get, L square and many more things you can get. Again, what will happen here? The same thing. This D dot L and this L, you can just check it out. Okay, we have already seen in our previous example. If you consider here, in this example, we have already seen this was our DL and union DL union L. This example we have already seen. The same situation will happen here. So in this L, okay, this is our L. Sorry, this was D here. Now this is our L. In this L, this D was telling us whether to check in this part or whether to check in this part. But now when you do this L union DL, then what will happen? Then because of this DL, this D will come here also, this D will come here also, and because of this L, you will get this also, this also. So basically, finally, this type of scenario will become, this type of scenario will happen. A power n, B power n, D A power n, B power k, C power n. So this is basically your L union D dot L. D dot L means D dot A power n, B power n, C power k union D square A power n, B power k, C power n. So again you can see, if your string starts with D, now I don't know whether to check this or whether to check this. If my string starts with D, then I don't know whether to match number of A with number of C or whether to match number of A with number of B. So this is a very simple example. In this we have seen that this is a DCFL language, this L union D. This is a DCFL language. Okay, but if I take the Kleene star of this language, then that is a non-DCFL language. So this language, this Kleene star, this language is not DCFL. So we have seen that Kleene star of DCFL may not be DCFL. So the set of DCFL languages is not closed under Kleene star operation. So I can say that if you have a DCFL and you take Kleene star of this DCFL, then again may not be DCFL. So these are the results that we have seen in this example. So we can say the class of DCFL, the class of DCFL languages, the set of DCFL languages is not closed under concatenation and Kleene star operation. And few more examples, few more theorems that we can say, few more results that we got is this: DCFL not closed under concatenation, DCFL not closed under concatenation with regular languages, DCFL not closed under concatenation with finite languages, DCFL not closed under Kleene star operation. Okay.